start with this particular equation. Now if you check, the spelling which is given is Debrogie. Most of us think it's de Broglie, correct? But the correct pronunciation is de Broglie. So, what is de Broglie equation? So, whenever we say Brogie, it's de Broglie. He was a French scientist, Louis de Broglie. He was a French physicist, okay? So, he suggested that light, they did some experiments and they concluded that light has both particle as well as wave nature. So we say lights have dual nature, correct? They have particle as well as wave nature. Now you must be thinking how they came to know. Well, there were many scientists who worked with it. You will have all this in physics. So right now we are not interested about light, but yes, since light has both particle and wave nature, we concluded that all material object has dual nature. They show dual nature. So if it's an object, a material object, it will have mass, means it is going to be a particle, and it will always have wave nature. Now you must be wondering, how is it possible? If you see any matter around us, any material which is around us, whenever you see that or whenever you throw that material, we will not be able to see its wave nature. What is the reason? Because these materials are big in size. So what you conclude, if you have small particles, very small, like electron, then you can see its wave nature also. So what do we conclude? Electrons have both mass as well as what? Wave-like nature. So it shows duality. It shows dual nature of both particle and wave. Are you getting it? Now, this scientist is Louis de Broglie. He said that if there is a particle with wave nature, obviously it will have wavelength, and since it's particle, it will also have mass, correct? So every object which has mass and velocity, please remember this, if it has mass, it will behave like particle. If it has velocity, it will behave like wave. So any particle which has both mass and velocity will have dual nature. So can electron show both particle and wave nature? Yes. Why? Because it has mass as well as velocity. Okay. Now this particular scientist de Broglie gave a relation, and he said wavelength of the wave is equal to this relation. We know h is Planck's constant. We know this is wavelength. What is this? Mass into velocity. Well, that is momentum. And momentum is denoted by P. So the same equation can be written as h upon P, P stands for momentum. So, if you check this equation, lambda is equal to h upon mv. Anything who shows wavelength means it has a wave nature, correct? Don't you think this is inversely proportional? So if any particle has got very small mass, its wavelength will be high and hence you can see its wave nature. But if the particle has got big mass, so its wavelength is going to be slow, and because of that we will not be able to see its wave nature. Are you registering this? Let me give you a simple example. It will be more clear to you. Whenever we play cricket or whenever there is a tennis ball or any normal rubber ball, whenever we throw it, obviously it's a particle, it has a velocity. But these tennis ball or rubber balls, they have wave nature. Yes, we can't see because their size is big. And if size is big, wavelength is going to be small. And because of that, we are not able to notice its wave nature. Okay, let's take an example. Just assume I have electron, I have a tennis ball. Okay, this is 0.1 kg and this is correct. This has mass, correct? Now tell me whose mass is bigger? Obviously, ma'am, tennis ball. Perfect. So now my formula is lambda is equal to h upon mv. If you see, what? If mass of the tennis ball is big, the wavelength is going to be small. Means we are not able to find the wavelength because wavelength is so small, means we can't detect its wave nature. But in case of electrons, its size is, its mass is so less that its wave nature can be easily seen. Hence, with the help of instrument, we have ways to know electron is showing wave nature. But a bigger mass objects like tennis ball, they have wave nature, but we cannot find it even with the help of instrument. So what we conclude, heavier particles will possess smaller wavelength, whereas light particles will have longer wavelength. And longer wavelength means we can easily see its wave nature. Is that okay? So we will have numerical based on de Broglie equation. What is the formula? Lambda is equal to h upon mv, or in place of mv they may take p. What is p? Momentum. I hope this part is very clear. These are few postulates or statements of de Broglie equation. Okay. Now, he predicted and confirmed with an experiment that electron shows interference. It also shows diffraction. All this you have in physics, wave properties. Okay. So electron shows interference, they show diffraction properties. Whatever properties the waves have. Because diffraction and interference is a characteristic property of waves. Okay, now Now we are going to find wavelength of electron with the help of de Broglie equation. What is the formula? Lambda is equal to h upon mv. Okay. What is h? Planck's constant. Correct? Next. What is the mass of electron? And what is velocity? Is this much okay? Now when you solve this, what is the unit of H? Joule second. What is the unit of mass given here? It's going to be in kg. And what is velocity? Yes, it's distance upon time. The distance can be centimeter, meter, whatever. And time is going to be in seconds. Correct? So when you solve this entire thing, your answer comes to. And this will be centimeter. I want in meter. So if you want in meter, it will be this. And what is this? Okay. So the wavelength which is here shown is 3.32. And this wavelength is measurable. You can measure it. And hence electrons are having wave nature. Okay. Now the equation which we just solved, and we got answer approximately 3 into 10 raised to minus 10 meters. Now some of you must be having confusion how from these units we ultimately got meter. Correct? So I'm going little out of the track to make you all understand. So please pay attention. Same thing I am explaining now, but without numbers. Please understand what I am doing. The lambda got unit meter. I am just explaining you how we got meter from these units. You have units and dimensions in your physics. But here just remember, joules is given by this. What is it? Kilogram, meter square, per second square. Okay? So now just be alert and pay attention to what I'm showing. Let me just remove this. Okay? Now, I'm just bothered of the units. We know H is in joules second. We also know the mass is in kg. And we know velocity is meter per second, which ultimately becomes joule second square kg m. Is this much okay? Now what next? We will substitute this here. And when we do so, we get kg meter square, correct, upon second square. But we already had these. Are you getting it? Clear? Now, this gets cancelled, this gets cancelled, this gets cancelled. So what we are left with? Just meter. No one will ask you this. Then why I gave you explanation? because there is possibility you may think how h Planck's constant, mass kg, velocity meter per second gave me ultimately the unit of wavelength.